In this video, I will walk you through free response question number 3 from the 2010 AP Calculus exam. This is an accumulation problem about people waiting in a line. It's based on this graph of the rate at which people enter the line. This is a calculator active problem. However, we don't really need the calculator to solve the problem. There are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate, R of t, at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. Part A. How many people arrive at the ride between t equals 0 and t equals 3? Show the computations that lead to your answer. Here is one version of the first fundamental theorem of calculus, and I want you to burn this into your brain. It's one of the most important things that you will learn in the second semester of AP Calculus. The integral of a rate from A to B is equal to the net change in the amount from A to B. In this case, we have the integral of the rate at which people enter the line from time 0 to time 3. So the integral of this rate will equal the number of people entering the line from time t equals 0 to t equals 3. We are given the graph of r of t. To calculate the integral of r of t from 0 to 3, we must find the area under the curve from time 0 to time 3. So this area represents the integral of r of t from 0 to 3. Always keep in mind what this means in the context of this problem. The integral of a rate is the change in amount. In this case, the integral of this rate is the number of people who entered the line. Let's divide this area up into smaller areas that we can easily calculate. At first glance, I'm thinking this rectangle has an area of 12 because I see 12 squares. But let's be careful. Each square is actually worth 200 people. Look at the units on the x-axis and the y-axis. Each square has a width of 1 and a height of 200. So the area of each square will be 200. So this rectangle that's made up of 12 squares is actually 12 times 200. So this will be 2,400 people. This little rectangle right here, this 2 squares is 2 times 200. So this will be 400 people. Looking at this little triangle right here, 1/2 base times height. Well, the base is 2, so that's 1/2 2 times, and the height is 200. So this represents 200 people. Similarly, the triangle on the upper right is 1/2 base times height, 1/2 1 times 400, which is also 200. So this sum represents the number of people who entered the line from time t equals 0 to t equals 3 hours. Anyway, we found that the value of the integral from 0 to 3 is this sum, which turns out to be 3,200 people. Don't forget your units. And the bottom line is 3,200 people arrive at the ride between t equals 0 and t equals 3 hours. Part B. Is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Justify your answer. The easiest way to decide if the number of people waiting in line is increasing or decreasing is to compare the rate in versus the rate out. The rate in is given by the function r of t. That's the graph that we are given, which shows the rate in at various times. What do we know about the rate out? The rate out is mentioned right here. People move onto the ride at a rate of 800 people per hour. So if people are getting on the ride, they are getting out of the line and going on about their day. So the rate out is 800 people per hour. 800 people per hour are getting on the ride and leaving the line. So now we just need to figure out if the rate of people coming in is greater or less than the rate of people going out on the interval from t equals 2 to t equals 3. If people are coming in faster than they are going out, then the line will be getting longer. If people are entering at a slower rate than they are leaving, then the line will be getting shorter. So let's look at the graph and analyze the interval from t equals 2 to t equals 3. Notice that at t equals 2, r of t is 1,200 people per hour. In other words, at this time, 1,200 people per hour are entering the line. Notice that at t equals 3, people are entering the line at a rate of 800 people per hour. So, on the interval between 2 and 3, people are always entering at a rate faster than 800 people per hour. The number of people in line is increasing because r of t is greater than 800 people per hour for values of t between 2 and 3. Part C. At what time t is the line for the ride the longest? How many people are in line at that time? Justify your answers. If you truly understand the information that the graph is giving us, you can answer this question intuitively, showing very few calculations. Before we look at the graph, let's remember what we discussed in Part B. People are leaving the line at a rate of 800 people per hour. So, if people are entering the line at a rate greater than 800 people per hour, then the line is getting longer. If people are entering the line at a rate less than 800 people per hour, then the line is getting shorter. This purple line represents a rate of 800 people per hour. This graph of r of t represents the rate at which people enter the line. Before this point, people are entering the line at a rate greater than 800 people per hour. After this point, people are entering the line at a rate less than 800 people per hour. We can see that the change happens at time t equals 3. Before this time, the line gets longer. After this time, the line gets shorter. The line gets longer for values of t between 0 and 3 because r of t is greater than 800. The line gets shorter for values of t between 3 and 8 because r of t is less than 800. So, the line is longest at t equals 3. But the question also asks how many people are in line at that time. The number of people in line will equal the initial number of people plus the number of people who entered the line minus the number of people who left the line. In the setup of the problem, we were told that there are 700 people in line when the ride begins operation in the morning. So that's the initial number of people. In Part A, we found that 3,200 people entered the line from time t equals 0 to t equals 3. So the number of people in line at time t equals 3 will be 700, that's the initial number of people in line, plus 3,200, the number of people who entered the line between t equals 0 and t equals 3, minus the number of people who left the line between t equals 0 and t equals 3. Well, that is a 3-hour period. And we know that 800 people per hour are leaving the line. So 800 times 3 is 2,400. So that's what we must subtract. That's 1,500 people. Let's add that to the summary. The line is longest at t equals 3 when 1,500 people are in line. That was the fastest way to solve the problem, but you could also answer the question using a candidates test. Here is an equation that represents the number of people in line at any time t. Of course, the 700 represents the initial number of people in line. This integral represents the number of people who join the line between time 0 and time t. This is an integral defined function. T is the real variable. I'm using x as a placeholder. When you have a variable for one of the limits of integration, you have to use a different variable for the function. The minus 800t represents the number of people who are leaving the line between time t equals 0 and time t. We know that 800 people per hour are leaving the line and getting on the ride. From 0 to t, we're talking about t hours have gone by. So it makes sense that the number of people leaving will be 800 times the number of hours, or 800t. To make a candidates test, we need the critical values, and we get the critical values by setting the derivative equal to 0. So how do I take the derivative of this whole function? Well, the derivative of 700 is 0. According to the second fundamental theorem of calculus, if we take the derivative of an integral like this, the derivative and the integral sort of cancel each other out, and we are left with the function r of x, but we write r of t because that's how the second fundamental theorem of calculus works. The real variable goes in for the placeholder. So that's that part. And then the derivative of minus 800t is simply minus 800. So to get the critical values, we take this derivative and we set it equal to 0. Adding 800 to both sides, we have r of t is equal to 800. And this is when we would look at the graph and see, okay, at what value of t does r of t equal 800? Well, that's right here at t equals 3. So t equals 3 is our critical value. Now let's make the candidates test. Our candidates for times with the most people in line are 0, 3, and 8. The 3 is our critical value. The 0 and 8 must be included because they are the endpoints. The park is open from t equals 0 to t equals 8. In the setup, we are told that there are 700 people in line at time t equals 0, so that's done. To calculate the number of people in line at time t equals 3, we will use this equation. So 700 plus the integral from 0 to 3, we're talking about t equals 3, of r of t minus 800 times t, which is 3. The integral of r of t from 0 to 3 is what we found in part A, 3,200 people. So that's your 700 plus 3,200 minus 2,400, 800 times 3, which gives us 1,500 people in line. Similarly, to calculate the number of people in line at time t equals 8, we do 700 plus the integral of r of t from 0 to 8 minus 800 times 8. To calculate the integral of r of t from 0 to 8, we need to find the total area under the curve between 0 and 8. We can start with the 3,200 area that we found previously, but then we need to find the rest of the area. So dividing the rest of the area up into triangles and rectangles, we get 1,200, 200, and 400. So the total integral can be found by adding all of these areas together, which turns out to be 5,000. 8 times 800 is 6,400. So when you add them up, you get negative 700. You can't have negative people in line, so at some point before time t equals 8, there are 0 people in line. For the summary and justification, we say the line is longest at time t equals 3 hours when there are 1,500 people in line. See Candidates Test. This Candidates Test method does take a little bit longer than the first method I showed you, but I think it's good to have a backup plan in case the first method doesn't occur to you. Also, I'm glad we went through this because it gives us a chance to make some connections between a lot of the concepts we've been learning during the second semester. Part D. Write but do not solve an equation involving an integral expression of r, whose solution gives the earliest time t at which there is no longer a line for the ride. Remember that equation we used for the Candidates Test? Let's use that equation again for Part D. Again, this equation is saying that the number of people in line will equal the initial number of people in line plus the number of people who enter the line from time t equals 0 to some unspecified time t, minus the number of people who leave the line after t hours have elapsed. If there is no longer a line, that means the number of people in line is equal to 0. We are not supposed to solve the equation, so this is the answer.